Let's run through complete solutions to free response question number 2 from the 2025 AP Calculus AB exam. Now, this is a calculator active problem, so make sure you have your calculator beside you so you can follow along with me. Let's dive in. So, in this free response question, we are working with this region R sandwiched between these two graphs, y equals f of x, y equals g of x. We're given the rules for f and g, and we're asked to calculate various areas and volumes, that sort of thing. So in part A, we're being asked the straightforward setup, calculate the area of the region R. We have to show our work to get full credit, so let's make sure we set it up correctly. Now notice the top curve is always on top, so y equals g of x is always above the curve y equals f of x. So that means we're in the nice situation where we're just going to take the difference of the rules, calculate our definite integral. We are going to need our calculator, so let's make sure we have that handy. So we're showing our work, so we're going to integrate from x equals 0 up to x equals 3, because that is the bounds of my region. And then I'm simply going to take the top curve, which is giving me the y coordinate of the upper part of my region, and I'm going to subtract the lower curves, because that's giving me the lower y coordinate. So I'm going to subtract those, take my integral with respect to dx, because that difference is giving me the height of that cross-section of that region. So, I could write down the rules here for f and g, but if you look at the scoring guidelines, this is perfectly adequate. We'll get full credit for showing our work, and why waste time writing down these complicated rules when we don't have to. So, let's pull up our calculator here to actually figure out our answer. So, I need to hit math and then entry 9 to calculate an integral. Now, as I said, do follow along on your calculator. If this is something you're a bit rusty on, I would encourage you to watch my calculator skills video. I run through the 4 skills you absolutely need to know to be successful on the AP exam. I'll put a link in the description, but for now, I'm going to assume that you're okay with calculating these integrals on our calculator. So I need to type in my limits of integration from 0 up to 3. The rule for g of x, okay, I'm going to use parentheses to keep everything nice and separate. So g of x is x plus sine of pi times x, close parentheses, I'll close parentheses, because now I want to subtract the rule for f, which is just x squared minus 2x. Close all my parentheses. Now, I have, my final answer is 5.137 when I round it. 5.137 to 3 decimal places. And that's it. So how are the points divvied up here? Well, let's take a look. We get 1 point for actually setting up the integral correctly, and we get a second point for our correct answer. Good job. Okay, in part B, we kind of up the ante a fair bit, because in part A, we were working with the area of a 2D region. We could visualize it really nicely. In part B, we're calculating the volume of a 3D solid. It's quite a bit trickier to visualize, but the great thing about math is we actually don't have to have a good visualization of it to work with it and get our answer. So we are told that R is going to be the base of our solid, and whenever we take a cross-section, a slice, perpendicular to the x-axis, I'm supposed to get a rectangle. So let me show you what this is going to look like. So I'm taking my slice perpendicular to the x-axis, and I'm supposed to get a cross-section that's a rectangle. Okay, so it's going to look something like this. Okay. If I take a cross-section at a different point, maybe over here, I get that same nice slice in the region R, but over here my x value is a lot larger, And so the rectangle that I get, which is supposed to have height x, is going to be a lot larger also. Okay. It's a little bit counterintuitive because of how it's set up. The height is really sort of the depth of the rectangle coming out at you. Whatever this little solid is going to be, it's going to be some weird cake. When I slice through it to get a slice of the cake, I get these rectangles, but the overall shape of the cake is something kind of weird, kind of out there. So let's see what happens. So when I take a slice at a certain x coordinate, okay, the height of that rectangle here is supposed to be x. What's the other area, the other side length of my rectangle? Well, it's just like in part A, because this side length is just like we calculated in part A, is going to be g of x minus f of x, right? Because I've got the top curve, that top coordinate is given to me by g of x. The lower y coordinate is given to me by f of x. So the length, that distance between those two black points I've plotted, is just the difference g of x minus f of x. So that's the size of these rectangles. Why am I so interested in the size of these rectangles? Well, the way into this problem is we're going to remember that we can calculate a volume as an accumulation of cross-sections, of areas, and that is just another way of saying calculate a definite integral. So here, we're going to calculate from 0 up to, again, 3 over here. That's the extent of the region R. And I want to calculate the integral of the area of the cross-section at each x along the way as I take my slices all the way from x equals 0 up to x equals 3. Well, the good news is the cross-sections are just rectangles, and we've already worked out what the side lengths are, so the area is just the product of those side lengths. So let's write out what this is going to look like here. I've got the integral 0 up to 3. Well, I have the one side length I know is g of x minus f of x. Now I just need to multiply that by the other rectangle side length, which is x, and integrate that with respect to x. I could worry about, again, writing down the rules for g and f, but I don't need to. This is perfectly acceptable justification showing of our work for the scoring guidelines. Well, this is another integral to calculate, so let's pull up our calculator. Now, we could take this in, but the great news is this looks very similar to the integral we worked with in part A, right? All we've done is we've added in a multiplier of x to the integrand. So I'm going to be a little bit lazy and run up here and take a copy of that integral. I'm going to go back into it and make sure that I just add in now that x that I want to multiply. Now I have a lot of parentheses going on here, so let's just make sure that it's all pairing up correctly. Okay, we've got x plus sine x, we've got the other difference, I've got those close together, I'm multiplying by that x, and then I'm closing the parentheses for the overall integrand. Great. So our final answer is going to be 7.705. Okay, let's see, how were the points divvied up here? Well, we got 1 point for our integral set up, okay, showing something like g of x minus f of x multiplying by x, and then we get, again, 1 point for our final answer. Nice work. Okay, in part C, they're again asking us to work with the volume of a solid, but they're giving us a little bit of a break because we don't actually need to calculate it. We just need to set it up, actually write down an integral, an expression that is equal to the volume. And here, the volume we are generating is via a rotation. We're rotating the region R around the horizontal line y equals -2. Now, when we hear volume via rotation, we're probably going to be thinking disk method, washer method, something like that. We just need to figure out the details and see which we're actually working with. So the way in to figure out if it's going to be a disk method or a washer method is to take a nice vertical slice down your region and see what happens to that vertical slice, that line segment, as we do the rotation about the line we're looking at. So when I look at this top point here, what happens to that point as it rotates around the line y equals 2, negative 2? Well, it's going to sweep out a circle for me. Something like this. Like that. And if I look at the bottom endpoint of that segment, when it rotates around y equals negative 2, it's going to give me a smaller circle being swept out. So the whole region itself, if you think of this pencil as being that green segment, when it rotates, is going to give me this washer. Okay, I've got the inner piece, but I've cut out that central circle given to me. So this should be making me think, aha, washer method. So I just need to figure out the radii of the circles in question, the large circle and the smaller circle. So again, we're integrating with respect to dx. It's all set up in the horizontal direction. Again, the region is bounded between x equals 0 and x equals 3. So I'll integrate from 0 up to 3. And now, remember what the washer method says? It just says it's the area of the big circle subtract the area of the small circle. So conceptually, that's what's going on here. All we need to do is remember, how does the radius of each of these circles relate back to the horizontal line and my rule F and G. So that's what we're going to be figuring out here. Now we could look at this and think, okay, I can work out my radii from first principles. So I could do something like, okay, this red point, I know that that distance is g of x. Okay, if I'm slicing at a particular x value, because that's the y coordinate. And then I know the distance I need to travel to get down to that horizontal line is vertical distance 2. So that is the radius of the large circle is pi times that radius squared. Well, we just figured out the total radius is g of x plus 2, and I'm going to square that. Okay. And you could do a similar sort of analysis to say, okay, what is going on with that smaller radius? But you can also just remember your formula for the washer method. And it's going to pair up really nicely here too. It is your function rule plus the distance out to your line, your horizontal line, and we're going to square that multiplied by pi to get the area of the smaller circle. So again, this is my overall expression for my volume. They have not asked us to calculate it, so let's not waste time. We're done. Great. How were the points divvied up here? Well, we're getting 1 point for the overall form of the integral. So something like the area of the large circle subtract the area of the small circle. Okay, so that's one starter point for us. We then get a second point for everything being correct inside the integrand. So having that g of x, f of x, the 2, the square, the pi involved, all correctly. That's a second point for us. A third and final point is for making sure that our limits of the integral and our dx are present. So we need to have a one correct set of notation there as well. That's our final third point. Nice. In this final part of the question, we're forgetting about area, forgetting about volume. We're actually forgetting all about R too, okay? They're asking us, these two graphs we've been staring at this whole time, they want us to find a point an x value between 0 and 1 where the tangents to these curves, to these graphs, are parallel. So the fact that we're looking for tangents being parallel, that tells me immediately I want f prime to be equal to g prime, right? F prime is measuring the slope of the tangent of f. G prime is measuring the slope of the tangent of g. When straight lines are parallel, that happens if and only if they have the same slope. So we've converted the question into solving an equation. The great news is they told us a rule for g prime, so that's coming at us for free. We have a rule for f. It's a polynomial, it's a quadratic, so we can write down straight away that f of x equals 2x minus 2. So we have a very concrete equation that we need to solve. So we want to solve 2x minus 2 is equal to 1 plus pi cosine pi x. We can type this into our calculator and solve this, no problem. So let's pull up our calculator. Okay. Now, first of all, I will say this is involving trig functions, so make sure that your calculator is in radians. I know you always think your calculator is in radians, but maybe your nemesis in class has been messing with your calculator and has put it in degrees. That would mess this all up for you. So before the exam, before you start to sit down to do some practice, make sure your calculator is in radians. Now, let's type in these two expressions as graphs. So I'll get 2x minus 2 as my first expression, and then I've got 1 plus pi cosine of pi x as my second expression. Now notice we're wants to restrict attention for x being between 0 and 1. So you don't have to do this, but I like to go in to my window and clear out the x range so that I'm really focused on the right region. Okay. So now let me hit graph. You can see I have these two graphs here. Okay, if I do this on my physical calculator like you've got, you'll see a similar sort of setup here. So these are the rules I've got for f prime and g prime. I want to find that intersection point because that will tell me where the slopes of the tangents are equal. So how do we do that? Well, hit second trace. I want to do a calculation. Bring up the calculate menu. It's going to be entry number 5, right, to calculate an intersection point. So in my calculator app, I hit 5. It asks me for a left bound and then a right bound. So I'll move over and sandwich like that. It gives me this intersection at x equals 0.676. On your calculator, right, it's similar. You're going to hit, whoops, second, calc trace. It's then going to be entry 5 for the intersection, but now it's just asking you for your first curve and second curve. So you're going to hit enter for your first curve, enter for your second curve, and then your guess. And so you can see it's the same intersection point. So x equals 0.676 when we round. And that's it. So how were the points given out here? Well, I get 1 point for writing down something like that equation, f prime of x being equal to g prime of x, and then I get 1 point for the correct answer. And that's all there is to it. And that is it. Another free response question from the 2025 exam in the books. How did you get on? Let me know in a comment. Did you deal with all these areas and volumes successfully? Some people love it, some people don't love it. As I said, if some of this calculator stuff is a little bit rusty for you, do check out my calculator skills video. If you get those 4 skills down, confident, mastered, you're going to be in great shape for all the calculator sections in the free response and the multiple choice, no matter what exam you are looking at. Apart from that, I will say looking forward to see you in the next video. Bye.